the first step is always the same. We want to take the derivative of both sides, which means we apply the derivative operator to both halves of the equation. Okay, so we apply the derivative operator to both halves. I did remind you about this last time, I believe. Did I tell you about this? Okay. So make sure you're using the right notation. Maya asked a really good question. She said, well, what if you just make a mistake? Mistakes are fine. That's not a big deal. What I worry about is somebody getting a little bit ahead of themselves and saying, this is too much work. I'm not going to write all this stuff. You might be okay for the simple problems, but then you will come to me for help for the hard problems, and I can't help you because your notation is so bad. So. Questions here? Okay. Look, for the 20 homework problems, you will find that once you pick up on the pattern, every problem starts to feel basically the same. All you do is look at this, and you try to find a substitute. Another point for Hannah. You're just looking for a substitute. You've got d dx of the square root of some expression. So you look through your rule set, and you find the correct rule. d dx of the square root of something. Note, here that something is referred to as being g of x. As you go step by step, g of x will change over and over again. Very good. So I just apply the rule. This can be abbreviated if you'd like as y prime. That's acceptable. So I have 1 over 2 square root of g of x. And then I finish with multiplying by d of g of x over dx. One thing to help you with your memorization, all these formulas do have to be memorized before the next test. Yeah, that's an AP requirement. I can't do anything about that. One thing that really helps is if you'll use my notation, you'll be very pleasantly surprised at how much you can memorize without really trying. Seriously, it'll just happen. One part of that is the end of each of these rules. Look at them. The end of each of these rules is the same. Feedback to the microphone. Seems like a scene out of War of the Worlds. Please.
How come g of x doesn't include the square root?
So I'm going to get you to see it for yourself. So just talk with me for a minute. So we've got d dx of the square root of g of x.
Okay.
So if it's d dx of the square root of g of x, the g is not part of the root. The g is what's inside the root.
Yeah.
So up here, what's g of x?
The square root of 5x squared minus 1.
No. The g of x is simply what's inside of the root.
So it's not, it's just 5x squared minus 1.
Does that, if it doesn't make sense, we want to keep talking. It's just 5x squared minus 1 because it's what is inside of the root. G is not, the root is not part of g. G is just the formula inside of the root. So up here, this is g. Does that feel good to you?
Yeah.
Sure?
Yeah.
Okay. The formula says that the substitution becomes 1 over 2 times square root of g multiplied by just d of g itself. The root is not part of that. The other thing that might help is that, so I'll ask you to fill in this formula, is the root a part of g or is the root not a part of g in the formula? If I go like this, is the root a part of 4? Is the root not a part of 4? Good. So right here it says square root of g. So is the root a part of g or not? It's not. So right here, d of g, there's no root. It's just g itself. There we go. 2 points. There we go. One reason it doesn't click initially is you still have kind of all of you do, you have a bad habit of being imprecise. You watch the teacher and you just kind of generally do whatever the teacher does. You don't pay attention to the symbols. You just mimic the teacher. You're very good at that. It just doesn't work here. Is everybody good? Awesome. Look. Another way to remember it is this. Well, look at me. The way this process always works, here I'm finding the derivative of the square root of something. The first rule I use is the square root rule. Okay, so this is the root. We'll just say the square root rule. That means this rule took care of the root portion of the derivative. That part is done. Now we need to find the derivative of what was inside. So we don't put another root, that'd be like starting all over again. That also might help. So. Please.
I was just about to say which step that would we go to the power step next? That was
2 points for Parker. The correct rule next won't be the power rule. What's the correct rule next? The addition rule. Because I have the derivative of two things being added. So next you'll write this. Y prime equals. Make sure you write y prime equals 1 over 2 square root 5x squared subtract 1. And this is what Matt was talking about. This single factor will now become 2 terms. Therefore, I must treat them as one large factor. Questions? That was the add subtract rule. The square root rule. Oh, please.
Is the negative d1 over the dx going to be 0?
Perfect. So in this problem, 3 for Michael for that one. Way back here, on our first example, we kept carrying this down just because I was showing you one little thing at a time. What Mike is noticing is a really good example of how quickly you will get much better at this and much faster. Because it doesn't take that long to start noticing things like what he noticed. This is 0, so there's no reason to keep writing it. This is 0. So on the next line, I will not write that any longer. Is it okay there? Please, Julie. Say it louder, Julie.
So will the 5 just, like, will we just not write it next time?
The 5 right here?
Yeah.
No, that one we can't discard
Okay.
It's not a constant.
because it's a multiplying constant. And the other problem, what we had was this. We had the derivative of 5 all by itself.
You didn't have a variable.
The derivative of 5 all by itself is 0. Here we have d dx of 5 multiplied by x squared. Okay.
Yeah.
Okay. Making sure.
I was just looking at the wrong thing. There's no children.
Yes, that's the next step. So this becomes 2 for Julia. This becomes, hey, this is 0. Is it good there? Next line is going to be this, y prime. Okay, do not do this. Forbidden. Okay? I'll tell you a quick story. Look, there's 2 things I've seen students do that will cause all kinds of problems. This, and I've also seen students get really lazy and stop writing dx. Third thing I've seen, they write capital D. Okay, this class is about precision. Okay, here's what's going to happen. Quick story. In July, you log on to the AP website, you get your score. If you do this on your test, or you forget dx, or you use a capital D, okay, here's what's going to happen. No, you'll see nothing. There's a little note that says your score will arrive in the mail. Like what? So you wait a couple of days. So I need someone who has great self-confidence, and a small little demonstration will not affect your confidence. So back here to Nick. So Nick opens. So Nick's like, you know, he does the little ditto marks. He like got capital D on his work. Leaves off the dx. He gets this package in the mail, like a big manila envelope. He opens up the envelope and says, "What the? It's my test." He starts thumbing through it. As he thumbs through his test, he keeps seeing this stamped like on different pages of his test.
Oh, you're an idiot.
Okay? And he's like, what? He gets to the very last page and it just says 0. Score, 0.
Wait, really?
It's like taking AP Lit and writing in your own language and expecting them to grade it. Okay? Look, okay, the story's obviously made up, but it does make a good point. Okay? I told the story last year. I didn't have a stamp, so Emily Downey was kind enough to gift me a stamp.
Have you ever stamped a student with it?
What's that?
Have you ever stamped a student?
I have not. I'm afraid I'd end up on the news. It's already on the video. There's some really good confidence for that one. So don't do that. Look. So rewrite it. So we go 1 over 2 square root 5x squared subtract 1. That became 0. Julia saw it. The next rule we need to use is the multiplying constant rule, because this is 5 multiplied by x squared. So we take out the 5. Okay, notice, when you start to have fractions, it's really, don't overcomplicate it. This is the top, this is the bottom. When I write the 5 right there, it's on the top. Okay? If you'd like to put a 1 under it, you can. You don't have to. You can even do this. You can kind of put the 5 in the middle. It still means it's on the top. Okay? Question? So I prefer to write like this. I think it saves me mistakes. So this is going to become 5 over 1. And then I still have d of x squared over dx. Questions to that? Please, Hannah.
Why did you use the power rule?
So I'm not allowed to use the power rule here because the power rule requires that I simply have d dx of something to a power. So in this situation, Hannah, what's being raised to the power?
Oh, just the x.
Just the x. So I have to move the 5 first. 2 for Hannah. Now I use the power rule.
So it can't be a constant next to it?
The power rule does not have a constant next to this thing. So, next line, y prime. If you'd like, you can start kind of cleaning up a little bit. When fractions multiply, just straight across. So this is 5, 2 square root 5x squared, subtract 1.
Is the 5
1 times 5 is 5. This times this times this is this. I need to use the power rule now. So I use the substitution, bring down the 2, multiplied by whatever g of x happens to be, which is x, new exponent. Last step is always the same, d dx of the g function. Which is just 1. We want to talk more? Please.
Can you, like, so instead of multiplying the 5 straight across, can you just have it multiplying 1 with 2x squared and then that's 10x?
That's totally legal. Just make sure you recognize that what you have here is one big fraction.
Yeah.
One big rational function where you have this times this times this, so the order doesn't really
So
matter.
then it's on top of it.
Yeah, they'll just write 10x.
Okay.
And then they'll notice something of importance. So written portion of the test, you would now stop. Multiple choice, you probably have to go one more step. Okay, rule. You must memorize this rule, so flashcard it if you need to. When you see a fraction, don't ever divide until you ask yourself, is the numerator factored? Can you view the numerator as simply chunk times chunk, or stuff times stuff times stuff? So just say it out loud, please. Is this numerator factored? Yes or no?
Yes.
Louder?
Yes.
Okay. What are the factors of the numerator? 10 and x. I can see two things multiplying to create the numerator. It's all a matter of perception, but you must have the correct perception. I see this as being 10 multiplied by x. So this numerator is factored. Is the denominator factored? Yes or no? Yes. The factors are 2 and root of 5x squared minus 1. Those are two pieces that are being multiplied. I can see the denominator as simply two things being multiplied. Okay, get rid of these. Okay, look, all of you came to this room with this really bad rule. You say things like, oh, you can't divide because it's plusing. You can't. People say that all the time. You can't divide because it's minusing. Okay? That rule will trick you. Like, you'll be going along just fine, then you'll hit a problem in this class where you'll think, that's why I can do it, and it won't work. Memorize this rule. The top must be factored. The bottom must be factored. And you can only divide factors. So the 10 does divide with the 2 because they're both factors. So look at the bottom. The bottom is really, at this point, one big factor. 5 is not a factor of the bottom because you can't think of the bottom as being 5 times something. That's why it's not a factor. It has nothing to do with being inside of something. It's like, is the bottom 5 times something? Yes or no? No. So the bottom's not a factor. That didn't make no sense. 5 is not a factor of the bottom. Okay, want to talk about it more now that I've ranted and raved? Okay. It's really simple. When you look at the bottom, just ask yourself, what is being multiplied to create the bottom? Nothing, really. Like, you can't see it as like chunk times chunk. So there's just one factor. And unless this factor is divisible by a factor up here, you don't divide. So you don't go dividing those 5s. Because the 5 on the top is a factor, not on the bottom. Yeah?
Those are factors of each other.
Say again.
Are you saying that they have to be factors of each other? Like that?
They have to be divisible factors. Yeah.
So the reason, well, give us an example of something that would be able to divide the bottom.
So a common mistake is this.
Where would we be able to simplify the bottom and the top? Like, you just take the top.
So if the bottom is 5 times something,
Yeah.
or x times something, then you can divide. because the top has factors of 5 and x. We'll see more examples as we go on. Okay, next example. We're done here.